Hey everyone, this is Wojo. Today we're going to look at graphing quadratics by hand. Let's just get going right at it here. We're going to talk about all these main ideas. First thing you should be able to fill out is whether it's a stretch, a shrink, or neither, and if it's a reflection or not. All of those can be found by looking at the a term, which in math is the number in front of the x squared. Now remember, if there's not a number in front of the x squared, we can always assume it's a 1 because multiplying by 1 is not going to change anything. And so if we want to look at that number in front of the x squared, in this case it's a 1. If we look at the absolute value, if we look at just the number itself, if the number is bigger than 1, then we say it's a stretch, and a stretch just means that it's going to be a skinnier parabola. If this number is between 0 and 1, after we ignore the negative sign, then it's going to be a shrink. It's going to be a little bit wider one. If the number is exactly 1, then it's going to be a neither, and it's going to be what we say is like the parent function. And so in this case, the number is exactly 1, so we're going to circle neither. We can also tell whether or not the parabola is facing up or facing down based on the number out front. If it's positive, it's facing up. Facing up are ones we say are not reflections. The ones that face down are reflections. Since this is positive, we would say, nope, it's not a reflection. We also can find the AOS, which is the axis of symmetry. We can find the vertex, which is that turnaround point. We can find the y-intercept, and we're going to introduce something called zeros today. But before we do any of that, the y-intercept's the next easiest thing to find. That's always going to be our c value in a standard form quadratic. A is 1, b is 2, c is -3. So we know our y-intercept is 0, -3. It's 0 because if it's going to be on the y-axis, it doesn't move over at all. So we can plot in that point 0, -3. Now to find the vertex, the turnaround point, which is going to be very helpful in graphing a parabola, we can first find the axis of symmetry. The axis of symmetry is found by using the equation x is equal to -b divided by 2 times the a value. This is a formula that will always help you find the axis of symmetry. It should look fairly familiar. It's part of the quadratic formula. And so we're going to do it kind of the same way. We look at the b term and then find its opposite. So up here, a is 1, b is 2. b is a positive 2 because it's a plus 2. So the opposite of b, the opposite of positive 2 is -2, divided by 2 times the a value. Now the a value is 1, so if I did 2 times 1, that just gives me 2. So my axis of symmetry is -2 divided by 2, which is -1. We would say x is equal to -1. Now remember, the axis of symmetry is that line, that kind of, there's a symmetrical line that goes right through a parabola and kind of cuts it right in half. And so now we know the line that cuts this parabola in half is that x is equal to -1. I'm going to draw a dashed line just showing that this is the line of symmetry. It's not actually part of the graph. It just helps me figure out other points on the graph. Now because I know this is a line of symmetry, I can also get another point just off of my y-intercept. If this is my y-intercept and it is 1 away from the line of symmetry, on the other side would be another point, its reflection point on the other side. So that is going to be its reflection point. We can mark it down, you don't have to. But that's where I got that from, is this is the reflection of the y-intercept. Now to finish graphing this quadratic, we would need at least one other point. That would be the vertex. I know the vertex has to be below these points because this is an upward facing parabola, but we don't know exactly where. But by finding the axis of symmetry, we actually know where our vertex is, at least in the x direction. Our axis of symmetry is always going to be our x value of our vertex. Every time your vertex is going to be the same distance over as your axis of symmetry. So my vertex is -1 comma something. All I have to do now is figure out what would the y value be for the vertex. I already found the x, now I just have to find the y. The easiest way to find the y is just by using the original equation. My original equation said y is equal to 1 times whatever your x is squared plus 2 times whatever your x is minus 3. If I want to figure out where the y value is when x is -1, I'll just take this equation here and plug in -1 everywhere I see it. Now you can use a calculator or you can do it in your head. -1 squared would be 1, because -1 times -1 is 1. 1 times 1 is 1, so this is going to turn into 1. 2 times -1 is -2, so it turns into 1 minus 2 minus 3. Well, negative 2, negative 3 is negative 5, plus 1 is negative 4. You could also have done it this way. 1 minus 2 is negative 1, minus another 3 is negative 4. So now it tells me my y value is negative 4. So I know my vertex is negative 1 over and negative 4 down. And so this is going to be my vertex. Just from there, I can draw the general shape of the parabola. It's a U shape that's going to go through those points, so I could draw that U shape. But we're going to introduce another, something else called zeros. Zeros are also called X intercepts, so it's good to kind of know that both of those words mean the same thing. And so I could say, I can find my X intercepts, or my zeros. Now remember, X intercepts are where they touch the x-axis. Where they touch the x-axis, the y value is 0. If you think about it, anywhere they're going to touch the x-axis, which it looks like it's going to touch the x-axis maybe right here, and maybe like right here. If I was just to guess, I'm going to say 1 and negative 3. But these points are going to have an x value, and they're going to have a y value of 0 because there's no height. And so when I look at trying to find my zeros and x-intercepts, I want to find when is my y value equal to 0. So if you kind of look back at this equation, if I wrote up here y is equal to x squared plus 2x minus 3, that was my original equation. I want to know what x's make the y turn into 0. So I'm just going to take this y into 0, and I'm going to solve it using the solving techniques we learned in the last unit. There's many ways to solve a quadratic. You can factor, you can use a quadratic formula, you can complete the square. Factoring is always the fastest if it's factorable. Now, it's a plain x squared, so that's a good sign. And this is a trinomial, so we could think about factoring it with our factor x's. Is there numbers that multiply to negative 3 that add to 2? Yeah, there actually is. Positive 3 times a negative 1 would multiply to negative 3. And 3 minus 1 is 2. So I could rewrite this in factored form, which would be an x plus 3 and an x minus 1. If I went to solve that, remember ZPP says if these are equal to 0, I could get x is equal to negative 3, because negative 3 plus 3 is what would give me 0. Or, to cancel this out, x minus 1 is equal to 0. What would cancel out a minus 1 to turn it into 0? If I just looked at just that part there, x minus 1 is equal to 0, well, x would have to be 1, because a positive 1 minus 1 is what gives me 0. So x could equal 1. These two values are the two values of x's that turn the y into 0. So these become our x-intercepts. So for our zeros, or our x-intercepts, one of them is negative 3 for the x when the y is 0, and the other one is 1 when the y is 0. And those are pretty much what we guessed when we looked at it. We looked at it, we said, yeah, 1 should have been one of them, and negative 3 is one of them. These just give me a couple more points to graph my parabola. Now if I went to graph it, I know it's going up, it turns around at this vertex, and it goes through all of these points. So that just gives us more information about our parabola. And the way we find the zeros is by just setting the y to 0 and solving for the x's. Now if factoring didn't work, or we didn't know how to factor it, then maybe we'd have to use the quadratic formula. So the next example is one where we might have to use the quadratic formula, but we'll go through it much quicker. So if we look at number 2, we look at this, it's a 0.5. It's positive, so it's not a reflection, but it is a number smaller than 1, between 0 and 1, so we're going to say it's a shrink. The y-intercept is negative 4. Axis of symmetry is negative b over 2a. In this case, the b value is negative 1, so the opposite of negative 1 is 1, divided by 2 times a. Now a is a half, or 0.5. If I said, what's half of 2? Well, that's just 1, so 2 times 1 is 1. So we have 1 divided by 1. That answer would be 1. So our axis of symmetry is at 1. Our y-intercept is at negative 4. Our axis of symmetry is at 1. So we know that this is a reflected point, same distance here and here. We also know that our vertex is going to be 1 over because of that. And I can plug in 1 into this equation to figure out how high up my vertex is. So if I go to plug this in, I have 0.5 times 1 squared minus 1, because that's my x, minus 4. 1 squared is 1. Half of that is 0.5. Negative 1 minus 4 is negative 5, plus that half. Looks like it's going to be negative 4.5. You can always use your calculator if you're not sure how to do it in your head. And you can just grab your calculator and type in what you wrote. So in my case, I had 0.5 times 1 squared minus the 1, because my x value is 1, minus the 4. So I can just type in what I have written right here. And you can just double check that you have the right answer. It is indeed negative 4.5. So my vertex is going to be right here. Now when you have points that are so close to the vertex, it's still kind of hard to figure out where your X intercepts are going to be, how wide to make this. I can kind of guess. Maybe it's going to be 3, maybe it's going to be 4, but it's kind of hard to tell. So we're going to now look for our zeros. To find our zeros, we're going to set our y value equal to 0, because that's where our X intercepts are going to be. So I'm going to have 0 equals 0.5 x squared minus x minus 4. Again, I just turn my y up here into a 0, because that's when it's going to be a 0. That's when my x-intercepts are going to always have a y value of 0. We just got to find the x to make it true. Now last time we factored, but we've never factored with a coefficient of 0.5, and so this might be one that's good to use the quadratic formula. And remember, there's lots of ways you can solve a quadratic. If I'm using the quadratic formula, a is 0.5, b is negative 1, and the c value is negative 4. And so I would use the formula x equals negative b plus or minus square root b squared minus 4ac divided by 2a. So I'm going to replace all these a's and b's and c's with the numbers they represent. So opposite of b would be the opposite of negative 1, that's 1, plus or minus square root b squared. Now I can do that in my head. Negative 1 squared means negative 1 times negative 1. So that's 1 minus 4 times a, which is 0.5, times c, which is negative 4, all divided by 2 times my a value. 2 times 0.5, again, if you need your calc, you can do it. But 2 times a half is just going to be 1. So you can just do 2 times 0.5. So my denominator is going to be 1. If I just do the inside of the square root on my calculator, I can simplify this a little bit. And so if I just do the inside, the 1 minus 4 on my calc, I get 1 minus 4 times the a times the c. The inside of my calc would give me 9. And so all of this here turns into 9. And now I just have this to clean up, the 1 plus the square root of 9 divided by 1, and 1 minus the square root of 9 divided by 1. And I can do that on my calculator if I want. Although square root of 9 is easy, we can still do it on our calc. 1 plus the square root of 9, hit enter, divided by 1. One of my answers is positive 4. So one of my x's is positive 4. To get the other one, I have to now do 1 minus the square root of 9. So I would come up here, 1 minus the square root of 9. And don't forget to divide it by the 1 at the end. I would get negative 2. So my zeros are at when x is 4 and x is negative 2. Now I can come over here and double check to make sure that makes sense. X is 4, yep, that looks right. X is negative 2. Yeah, that looks right. Now I have a great idea of where my parabola is. Now you wouldn't have to necessarily find every one of these points to get a good sketch. You probably could have got it right off here, or you could have just done the the vertex and the zeros. Depending on the problem will kind of depend on what kind of information you want to find. We're just practicing finding all the information, and then in the next week or so we'll be looking at how you can make a decision on what information you actually need. Feel free to watch this video a couple times to make sure it makes sense. If you have any questions, as always, come see me. Thanks a lot.